One way to separate individual chemicals in a mixture is called chromatography. Chromatography can be used either to purify samples to determine chemical components and their abundances in the mixture, or both. There are several different types of chromatography, but they all rely on the same principle. A sample is dissolved in a liquid known as the mobile phase. The mobile phase passes through a structure known as the stationary phase. The constituents of a mixture will travel at different speeds because they each have varying degrees of attraction to the stationary phase. One of the most familiar types of chromatography is planar chromatography, where the mobile phase is drawn up a planar stationary phase, such as paper, or a thin layer of an adsorbent, such as silica gel. Paper is made of cellulose. Both cellulose and silica gel are polar, so nonpolar compounds travel faster through them. This separates the constituents, but does not always give the abundance of each constituent in a mixture. The retention factor of each constituent is calculated by measuring the distance the constituent traveled divided by the distance to the solvent front. You can do a type of planar chromatography at home. Take a glass and add a small amount of water. Then take a strip of paper and put a dot about 1 centimeter from the end with a wet erase marker. I find black is the most entertaining, though you can try other colors as well. Place that end in the water, making sure to keep the dot above the water line. After that, wait. If you want to prevent evaporation, then cover the glass. The water, acting as the mobile phase, will draw up the ink through the stationary paper phase and separate it. After about 15 minutes, look at the results. What color dyes constitute the color marker you chose? Another method of chromatography is known as column chromatography. With column chromatography, you pack a tube with a stationary phase, such as silica gel. You then add a dissolved mixture, which can either flow through or be forced through. The individual components can be collected as they elute through the column. They can then be dried and their masses taken to figure out the percent composition of each compound in the mixture. Then there's my favorite, gas-liquid chromatography. A heated coil, often several feet long, is coated with carbowax or some other material to serve as the stationary phase. Helium or some other inert gas acts as the mobile phase. A liquid sample is injected and heated, causing it to evaporate. After traveling through the coil, a detector senses when a compound exits the coil. The graph is then produced, and the individual areas show the amount of each compound present. Chromatography is not just useful in analyzing mixtures, it can also help someone determine the concentrations of any impurities in the synthesized products. Because of this, it is a very useful tool for chemists.